Okay, so can everyone see my Google page?
Yep.
Ignore my search history. So can we all turn to Tinkercad, please? And Google that. Basically, just choose the first one that pops up, Tinkercad, create. Right, now you guys are all going to come to a page like this. Yes?
Mm-hmm.
Lots of yeses, please, from people. And now you're either going to do sign in or join now. You guys are all going to do join now if you don't have an account. Okay, so just do that quickly. It takes no time. I've already got an account because it's Autodesk as well. So sorry, if you have an Autodesk account, you've used Fusion,
So yeah,
you should
same
be
as
able
Fusion.
to sign straight in with that. Okay. So use your Fusion sign in, and then can I get everyone to say yes when they're here? So guys, we're on this homepage. You should be able to see all of this, and basically Tinkercad, quite helpful. It's got 3D design, so you can do some 3D printing if Fusion 360 isn't quite your thing. It's a kind of aimed at a lower age group. You've got code blocks and you've got some lesson plans. We're going to choose circuits for this one. So if you all click on circuits, okay, and then you'll see some demo ones, I think. And you're going to choose create new circuit. I'm going to choose this one because this is one that I've got here. Okay. So I'm just going to hide that for a sec. Right, so you'll basically see a page that looks very, very simple like this. You can hide these banners in the corners. And what you can do is you've got kind of a library here of components that you can scroll through. Now we're going to go through the kind of components that we did on Tuesday as a recap for anyone else. And basically all you need to do is click on a component and you can drag it in. You can zoom in with your scroll. So you can zoom in over a component. And then once you've got a component selected, you can also choose names for it. So you can give it a name and you can choose kind of resistance values and such that we'll talk through in a little bit. Okay. Is everyone currently on this page? Everyone happy with this?
Yep.
Cool. You can also take a component, and while it's selected, it's obviously got this blue outline. You can either choose to rotate the object, and it will do that by tiny little. I think I want to say it's like 20 something degrees, 22 point something. You can rotate it like that, or you can just use R on your keyboard, which is also quick. You can also delete it, undo things, and view weirdly. Right, so we're going to take some basic components and we're going to start assembling a circuit. Now we're going to do kind of some testing first, just assembling, making sure that you guys all remember things. Now let's take a resistor and an LED. Okay. Now, if you want to join these two things together, we can do that with a wire. So you can join it like this, and you click on one of the points, it will draw a little wire for you. Anywhere you then click will then give you this jazzy little wire thing that you can do, and you can connect it up to another component. Okay? Everyone having fun drawing some ridiculously long wires like me? You can then also change wires. You can get them to align to each other, which is quite handy if you want to make things quite neat. And they'll kind of just snap into place. Okay. And then finally, you can also choose the color of your wire. So if you want things, we usually do power in red and black, and then you can kind of choose what other colors you want for this thing, right? So now we're going to choose a resistor, an LED, a battery, like this.
That's scaling top notch.
Yeah, amazing. And a push button. Okay. Can everyone get these components on their screen? And can everyone tell me once they've got that? And can I also make sure no one's lagging behind? I haven't lost anyone at this point. Chao-Wei, how are you doing?
Yeah, I'm good. Yeah, so just move the battery. And
yeah, just click on an object, bring it onto the board, and then bring on these components here. Oh, you can also change the color of your LEDs if you really want. Just a lot of fun here. Right. Some things I'm going to point out before we get started. As you know, when I click on a resistor...
I have a question.
Yeah.
So if I don't want the if I don't want to use these components, how do I delete these components?
If you delete a component, you can click on it and you can choose the trash can here,
Okay, cool.
delete, or you can just backspace on your keyboard.
Or hit the delete key.
Yeah.
Okay, thank you.
Yeah. So you got keyboard shortcuts for pretty much everything here. It's all fairly simple. Remember, guys, on your batteries, we've got our positive and negative terminals. Yeah, so remember which way those are facing. Whenever you click on an item, it will give you a bunch of, well, a selection here, right? Okay, so when I've got my resistor, I can choose its resistance and I can give it a name. Yeah. Let's resist. So this will help you identify things. When I click on the LED, I can choose its color and I can also give it a name. The battery, you get a little bit more of an option. You have one battery, you can choose all the way up to 4 batteries, okay? And think about how these are laid out in series and what the voltage and current. Can anyone tell me what the voltage of this is going to be? Rob, not you. Can anyone tell me what the voltage is?
6.
6
volts.
Yes, lovely
Yes.
stuff. Right, so you're going to have 6 volts. You can also choose different types of batteries, so you can change your voltage here, like so. And you can also choose to put a switch on it. Okay, so here you can basically run it. This won't work at the moment. I'll explain in a second how you do that. But yeah, we're not going to put a switch on because we don't care about that right now. With the switch, you need to pay attention. These things are annoying as hell, and these are very annoying in real life for me. You've got a switch here, and you need to click on these, you kind of hover over these terminals, and you'll see it's got terminal 2A, terminal 1A, terminal 1B, and terminal 2B. Okay? Essentially, the switch breaks between terminals 1 and 2. Okay? So this left side is one side of your switch, and this right side is another side of the switch. Okay, so if I were connecting these things up, I might do...
It works as a cross as well, as I found out, because I've got it connected between...
You can do it like that, and as long as this left side, the side 1, you can do it to either one of these, and it's connected to one side of your switch. You don't have to connect to both of them, by the way, just one side of this switch, or side 2, okay? But if you were to do, and you can delete a line just by holding backspace, if you were to do this, you've just cut out the switch. You've just connected them to the same part of the switch. Yeah? So now that's redundant. That doesn't work. I would just say be careful, because if you choose to rotate this a number of times, you might lose your bearings. Okay? So just be careful with that one. Right. So taking a switch, I'm going to delete this because I can't bother to rotate it right around. Right. So what we're going to do now is I'm going to draw a circuit here. And I want you guys to connect it up, and then you're going to try and send in your screenshots, and we're going to make sure everyone's got this kind of on wraps. So we're going to put that to the side there. Put that. Actually, let's just start with, can you guys make me this circuit here? But I want, and we're going to go through all of these components. I probably should have lined up what components I wanted before. I want a switch in there. Scaling. Okay, so I want you guys to make me this. You can obviously tell what I'm kind of going for here, by the way. That connects up, obviously. Let's not get finicky, Rob. So I want you guys to make me this circuit. Okay.
Are we using a switch or a button?
So a button and a switch are exactly the same thing. Okay, so a switch will work exactly the same way as a button. It's just that a button is a push to make switch. Is that understood, or do you need me to go over that?
How do we actually access how do we make the circuits?
Okay, so I'm going to put this on this side of my screen. I'm going to go here. So we're trying to make this circuit here, okay? Using these components that we've got here. Also, if you want to pan, you can either just grab the screen and push your scroll key in. So we've got these components here. We've got our battery, which is this symbol here.
Yeah.
We've got our switch. Sorry, were you not at the Tuesday session?
I was. I just joined a bit late to this one, so.
No, that's absolutely fine. Just wanted to make sure. So we've got our battery, which is this object here. We've got our switch, which is going to be here. We've got our resistor that we're going to rotate, and we've got our LED, right?
Right.
Now, I want you guys to... Oh, so you're going to want 2 LEDs. Okay. You can also choose to copy and paste items as well, so Control-C, Control-V. Now, I want you guys to wire this up, and there's certain things that I'm looking for in your diagram to make sure that this is wired up the correct way. So I'm going to give you, let's say, a minute and a half. I time it. And then can people tell me if they need more time? Okay. All right. I'm going to go ahead and put this over here. So your circuit should have looked something similar to that. Okay. Now I went jazzy and decided to color code my wires. Some of you decided to do that. Now, just going through these, Rob and Luke, you basically decided to switch your red and your positive and your negative on your batteries the other way around, so that your circuit was basically running through your diodes first, which isn't end of the world. Daniel, for some reason, yours isn't loading for me. Fardin, if you take a look at yours, you've connected it up interestingly, but the LEDs are the wrong way around. So you've got your anode and your cathode wrong. So they're diodes. They'll only run in one way. So if you hover over your LEDs, guys, one of the legs will say anode, which is your positive, which needs to be connected to the positive side of your battery. And the other side will say cathode, which needs to be connected to the negative side. Okay, so if you follow yours through up this snake, you'll see that. And I think there's Christopher. I think Christopher's yours was fine. Umar, if you're there, can you see in your circuit, you've put yours in series?
Oh, yes.
So you put yours in series, and you've also put your LEDs the wrong way around as well, the anode and the cathode. So before you go making changes, anyone, I mean, you're happy to anyway, but what you can do now is you can basically click up here in this top corner, start simulation. Okay, guys? Click start simulation. It'll run like this, and then you can click on that switch, and you can watch your LEDs light up. Okay? Everyone happy with that? Yeah, we're making circuits now. Okay, so has everyone managed to get their LEDs to light up? Are people still having issues?
How can I make battery turn 90 degrees?
So click on your battery and then just press the R key on your keyboard or press this rotate button up here.
Okay, I see. Thank you.
No worries.
I'm struggling with you know how the wires connect at the end? Like, they're not different wires. So you know the wires that connect after the parallel?
This up here, this one?
Yeah, don't they just become one wire?
Yeah, so you could... Basically, I've just connected mine in parallel like this. I've just taken one of the legs from my LED to the other one.
Okay.
But yeah, this one I could have chosen, like some of you decided to do. Actually, this would make no difference. So I put that there. But I could then also choose, and this is where your own creative freedom comes into it. That's why there's no like exact way to do this. But this would also be a credible result. Yeah.
Oh.
There's no reason that doesn't work as well. As long as your cathodes are connected to your ground, it's fine. Okay, so has everyone managed this? Is anyone still struggling? Does anyone want me to check their circuits? I just want to make sure.
Yeah, I'm trying to connect the second LED, but it's not connected for some reason.
Trying to connect your second LED.
Yeah.
Check that you're not still running the simulation. You can only edit your circuits when your simulation is stopped.
Yeah, it's not running.
Okay, do you want to screen share and we can take a look at your problem?
Yep.
Okay, so I'll stop screen share and we'll let you do it.
A bit confused about the parallel bit because it's like I don't know. It just didn't make sense to me personally, but
Okay, well, so let's take a look at this circuit diagram. So this is the circuit diagram we're trying to replicate here,
yeah.
right? Oh, sorry, I've stopped screen sharing, haven't I? Sorry, I'll explain just in a second. Irma, have you got that? So you can only join from a component to a component.
Yeah.
So go click that and then hover over the other leg. Irma, you should be able just to hold over and then hold over this kind of other pin for a little bit and wait for that toggle to show up. Sometimes it doesn't immediately, like that. Okay.
Okay.
Have you got it?
Yeah, one sec.
Okay. Sahan,
Yeah.
looking at this circuit, so what we're basically doing is we basically are just joining this resistor, so this end bit here, to the positive ends are anodes on both of our LEDs.
Yeah.
So we could choose to drag this all the way out here and it wouldn't make a difference.
Yeah.
Right? Because as long as that top bit's connected to this bit, and as long as the end of this resistor is connected to the top of this LED, the right pin, then that's absolutely fine. It doesn't matter what the arrangement is. In the same sense, we tend to simplify circuits by drawing them like this, where they join here.
Yeah.
Right? Because it just looks simpler. But in reality, it would make no difference if I took this component and threw it all the way over here. Right? It's still connected to the same wire. And it still meets up where it needs to at the ground, just like yours has. Yeah, so that's all absolutely fine. Okay. Right, so has everyone kind of understood the concept of Tinkercad? Anyone need any help? Anyone still not getting their LEDs to light up? Sorry.
Ben, how do I put the green wires together?
How would you put what? Yeah, so you can't connect wires to wires. You can only connect terminals to terminals. Okay, so in this case, I don't know why it's being difficult. In this case, you can't connect like a component here, like a terminal, to a wire. So we can't connect it here like we would in the diagram. You have to connect that to your negative point on your battery, like that. Okay? And that's a horrible display of how to make a circuit, because now I've hidden that wire. Okay? Right, guys. So next bit we're going to do is we're going to add in some more useful tools. Okay, so I'm going to connect my cathode back up, and I really would make a good practice of why is that there? I really would make a good practice of kind of coloring your wires in colors that you're kind of going to understand what they are, because these things can get complicated. Anyway, we're going to scroll down on our list, and you're going to pull out our lovely little multimeter here. Okay. All right. We're going to pop that down. Okay. Has everyone managed to find the multimeter and pop it into their circuit?
Yep.
Yep.
Anyone having trouble finding the multimeter and putting this out? I'm actually going to do it that way. No. Okay, perfect. Right. When you click on the multimeter, the options you get are obviously to name it, because we love naming our ammeters. Then you can choose whether you want to measure amperage. Oh, I can't say this. Whether you want to measure the current, voltage, or resistance. Okay, so you can choose that. Now we're going to set one to amperage, and then you're going to copy and paste it, and you're going to set another one to voltage. Okay. Now I want you guys, using what we learned in the last session, if you weren't there, then just give it your best shot. I want you guys to measure the current through this circuit. Okay, I want you to measure the current. Sorry, I should probably be more clear there. How do I be... Rob, help me out here. How should I state this?
And state what specifically?
I want you to measure the current between the resistor and the battery supply.
So the current through the resistor.
Well, yeah, through any point here. I want you to measure the current through any point here. And I want you to measure the voltage through one of the LEDs.
Across.
Okay. Across one of the LEDs. Good terminology there, Rob. Okay, guys, so I'm going to give you 1 minute to figure out how to set that up.
Wait. You want current through the voltage through the LED?
Yeah, through one of the LEDs. Voltage through one of the LED, across one of the LEDs, and current through the resistor. Okay? And then can people
Okay.
let me know once they are at that point? Okay, so guys, what I'm going to do is I'm going to demonstrate now. So what we've got here is we've got our ammeter, and we're trying to measure the current going through our resistor. Okay, so what we're going to do is we're going to break up this wire, and we know, judging from what we did before, and I'm going to be that guy. I'm going to connect my positives and my negatives the right way around. I'm also going to color code that so I can see it again. Right, so basically we know that the current in series is always the same, okay? So up until this point, the current through all of this is exactly the same, which is why our ammeter, if you remember from our last session, needs to be in series with all of these components. And you could put your ammeter between here and here. I've decided to put it between my switch and my resistor. You could also choose to put it here, okay? And it would still be measuring the same current throughout here, okay? Now, the voltmeter that we've got here, if I want to measure across one of these components, I'm going to just slightly rotate it a little bit. I need to, we know that from our last session that the voltage is equal in parallel. Therefore, if we want the voltage to go through our voltmeter, the same as our LED, we have to put it in parallel to our LED. So we do exactly the same as we've put this in parallel with the first one. So we take the anode, I'm going to connect up to my positive, take the cathode, so take the negative, and we put it to the cathode, okay? The only difference you'll get from this, having it wired the other way around, is you might see a negative number, okay? So I want you all to start your simulation. And once you do that, you can see your current and your voltage. And when you click your switch, you can see it all running through, okay? So you can see that change. Now, if I had my terminal switched the other way around, so if I did like this, all I would see during my simulation is a negative number, okay? Because you've got it negatively going through, okay? Is everyone okay with that concept? I'm gonna check again. Umar. Yeah, that's good. Umar, you just need to put yours in for the voltmeter as well. Okay. Now I'm not
how
gonna...
come it shows a
Sorry, carry on.
How come it shows a voltage reading even though the button's not pressed?
The voltage here.
Yeah.
And I believe that's just to do with the fact that there is a minor potential difference between the legs on the LED. Rob, can you correct me, Prince?
I don't know. It could be thermal voltage given how small it is, but I don't know if this entire simulation accounts for any of that.
Yeah, my best guess would be the fact, I mean, like, theoretically, you'd say there's none.
Yeah.
But I think this model is just accounting for certain things, and I think that there's just a small potential difference between here. It might even be to do something stupid like wire lengths, or something ridiculous. But it's basically negligible because it's a millivolt, okay? So just kind of don't worry about this too much. But good question, good question.
Okay, thank you.
Right, good job, guys. So now we're going to move on to your next challenge. I mean, one thing you could do if you really wanted to prove a concept, I thought we might try, but I don't really think it's necessary. Essentially, if we take our ammeter here and we were to put an ammeter down each one of these paths as well, you would see that the current going through these two ammeters would be equal to the current here. So they would add up to this current here, okay? So if you want, you can choose to do that in your own time, but essentially you can prove using these ammeters and voltmeters what's going on in your circuit. Is everyone happy with that? We're going to move on though. Okay, now one thing I'm going to challenge you guys to do now, this is a big one. I need you to make me, that's right, I need you to make me, and I'm going to help you out here. I want you guys to make me a NPN transistor circuit like this. Okay, so we're going to forget about this for a little bit. Okay, now if you weren't at Tuesday's session, don't worry about this too much. I'll explain as we go along. But I need you guys to try and make me that. So what we're going to do, we're going to go over to our components and we're going to get an inventory together. I'm going to delete pretty much all of this. If you want to collect multiple items at once, hold down Shift and it gives you a little box. You can select a bunch of components and I'm going to delete them. Okay, so the first thing we need to do, guys, is we need to basically go shopping. We need to find what components we've got in this layout. So first, starting on our left, we're going to take a small battery. We're going to use a small battery here for our leftmost battery. We're going to get a switch. Okay, we're going to put that switch there. We're then going to get a transistor. Okay, is anyone falling behind? Please do let me know in the chat. We're going to pick out the NPN transistor. Make sure you choose the NPN. Okay, you're going to select the NPN. You're going to put that down. You are then going to get another battery pack, but in this time, we're going to use the 9-volt. Okay, so choose the 9-volt battery pack for this one on the right. And then finally, I want you guys to have a, oh, I've made a mistake in this diagram, a resistor and an LED. Okay, we need a resistor here. Okay, so I really should have put that in. Okay, guys, so I'm going to give you a few minutes to see if you can wire up these components correctly. Okay, this is kind of like your little challenge. The main thing I would point out to all of you is on your NPN transistor, look at the gates and they are marked for you. Sorry, look at the pins and they are marked for you, base, collector, and emitter. So make sure you get those the right way around. Okay, I'm going to adjust this diagram so it's actually correct.
It won't let me delete stuff.
Have you tried the bin up here?
Yeah.
And have you tried the backspace key as well?
Yep.
Delete key.
Try clicking in them in here.
Try
Are you still running the simulation?
Yeah, don't run the simulation. Stop that.
I'm not.
Just try refreshing your page. It might just be a lag thing. It's not terribly amazingly great software, but it kind of does.
Yeah, that works. That worked. I refreshed and it worked.
Cool. Right, so turn it off and on again. Simple hack. Okay, guys. So a few minutes just to basically put this circuit together. If there's anyone that's confused by this, can you comment in the chat and let me know if you weren't here on Tuesday's session or you just have no idea what I'm asking you to do. Please don't be afraid. There's no wrong answers. I'm just trying to get a scope of who we have here. All right, seems like everyone's got this nailed. So this is what your thing should look like. Ignore my second bunch of LEDs and ignore my multimeter. Doesn't really matter. But this is essentially what you should see. When you run your simulation and I connect this switch over, you should see that your LED lights up down here. I've just added another one up for fun. Okay, so basically all you need to do is make sure that you've got your LEDs and resistors and everything else wired the right way. But there you go, guys. That is your transistor. Does anyone need me to explain the transistor again, or has everyone kind of understood it? Please don't be shy. I don't want you falling behind. Fardin, perfect. Okay, so Fardin, essentially, all we've got here, this transistor here, right, or on this diagram here as well, has a base pin, an emitter pin, and a collector. Okay. Now, when we apply a positive current from our base to our emitter, so here we've got this little circuit on the left, and what we're doing with this power supply is we're applying a current flow this way from the positive to the negative through our base to our emitter, right? When we do that, so when we close this switch here and we apply the current through, I'll admit, when we apply that current through, the transistor essentially acts as a switch and closes the gap between the collector and the emitter. Okay, so essentially allows current to now flow this way through. So once we allow this, if I've denoted with a red line here, once we've got current flowing through here, it allows current to flow through this, right? So which is why when I close this switch, I let the current flow from base to the emitter, and now it allows the current to flow through. So we basically created a digital switch with our transistor. Is that okay, Fardin, or do you have any questions?
Yeah, I think I kind of understand it.
Okay. I would recommend looking up lots of like different things on switches and such. Now, one thing I'm going to do is I'm just going to demonstrate something just so you guys understand a principle. You can choose to do it if you want yourselves. I'm going to get rid of that switch, okay? And I'm going to pull in a potentiometer. Can anyone tell me what a potentiometer does again? Not you, Rob.
I wasn't planning on it.
You can vary the
Resistance.
resistance.
Sorry, either speak up or write it in the chat
The
because I
variable
can't.
resistor, you can change the resistance.
Yeah, so essentially we can change our resistance. So what we've got here is we've got two terminals, terminal 1, terminal 2, and a wiper in the middle. Okay. Now, if you want to really understand how this works, look up potential dividers. I'm just going to, Rob, can you put potential dividers in the chat so people can see that? Or just, sorry,
Link
just,
to them or just,
just
the
write
words.
down potential divider so that people remember. Essentially, what we're going to do is we're going to take one side of our terminal, so watching just my screen here, and we're going to put that to terminal 1. Okay. We're then going to take the other terminal and connect that to ground. Okay, so I'm going to take this and I'm going to connect it to the negative side of our battery. Okay, so this is just replacing our switch. Now I'm going to take the wiper and I'm going to connect that to our base pin. Okay, is anyone dare to tell me what might happen here? Anyone want to take a guess?
Oh, would be off, right?
Sorry, speak up a little bit. That's quite quiet.
The LED would be off.
Um,
Then when you change it.
what? So it'll turn this off. Yeah, so it's very quiet.
I hear someone furiously clicking a trackpad.
Okay, let me demonstrate what's going to happen here. Okay, or maybe I'll set that to. Okay, there we go. So now what we've done is we've essentially replaced our potentiometer with, sorry, our switch with a potentiometer. Okay, thank you, Prince. Cheers. Okay, so basically what we have here is we are varying the resistance, right? So we've got a variable resistor here now that is limiting the amount of current flowing through from B to E, okay? Now, as we do this, remember the switch will turn on and it will close the switch, but we can think of it more like a valve, okay? The more current that flows through B to E, the more current we allow flowing from C to E, okay? So this current affects this current. The amount, if we increase this current, we allow more of this. So when I've got my potentiometer here and I've applied a high resistance, right, no current is flowing. Now, when I gradually reduce the resistance on this potentiometer by turning the knob, you'll see up in the top right here, I want you to see top right up here and on the LEDs. As I turn the knob, can you see the LEDs suddenly get brighter and the current increases? Yeah. Now, it doesn't need a lot of change. I've got this on quite a low resistance, but essentially here, the potentiometer is acting like a cable. It's not there. It's allowing all the current through, and so all the current is flowing through from C to E. Okay, but now when I apply a bit of resistance to that wire, I'm essentially blocking the current here. None of the current's coming through to our transistor. We're closing this valve. Is everyone happy with that concept? Would you like me to keep going and explain it?
I get it.
Yeah? Is everyone happy with that?
Mm-hmm.
Okay, so it's basically just to prove to you guys that it's not on and off. It's like a valve. You can vary it. Yeah?
A lot
Okay.
of components are valves, aren't they?
Pardon?
A lot of components are valves.
Components and valves. Me too. That's why I go on about them all the time. Right, so now, guys, I'm going to set you a real challenge. I want you guys to now take a breadboard from your pile, from your library. Okay. And who can remember the layout of a breadboard?
all jagged lines on there. Like
Yeah,
dash,
they're
dash, dash, dash.
all dashed lines. So on the breadboard, all of these lines are connected together, and Tinkercad will even help you out. It will draw all of the lines in green that are connected to that one there, right? And the same thing happens with these lot. These lot are connected all across here, and these lot are all connected across here. I would like you guys to now take your circuits that we've just been doing with wires, and I would like you to take your NPN transistor circuit and put it onto a breadboard. This is quite a big jump because layout is important. So think about where you're placing the holes. And Rob, could you also have an attempt at this as well?
Right, okay.
Is everyone happy with the challenge that I've set them, or do people need me to go over breadboards and how they work? My only bit of advice that I would offer people, one thing that's useful is not to destroy your circuits, but to kind of like start a new one. So try and use this as a frame of reference. Don't just take all the components from it. And also, it's quite handy, the fact that they've given you rails. You can take a positive rail and a negative rail. Okay. I will be awarding marks for neatest diagrams.
Does the circuit want 2 different voltages? Is it sensitive to it?
No, I've just specified doing 2. I'm trying to highlight, Rob, this is clever from me. I'm trying to highlight that a smaller voltage can open and close your transistor, while a larger one can be used to amplify whatever you're using.
Right, okay.
So it's just for the case of a Ben point, a lecture teaching moment.
Can I ask a question?
Yeah, of course.
What does the breadboard do?
Okay, so that's a great question. Basically, if you look at this circuit that we've made up here, you might notice that basically all of these components are just connected together with wires. However, if you were to try and connect these up on a table, like in real life, you would have a nightmare of a time doing it, because all of these wires would have little ends that you'd have to twist together or solder, and basically it becomes a very fiddly business because all these components are very small. So we use a breadboard because essentially all it has is these tiny little holes in it. So let me pull up a picture of the bread.
I can demonstrate. I've got a live one here.
Oh, thank you. Perfect.
Let's see if I can get it on camera.
So this is what a breadboard looks like in 3D. Like this. And essentially it's just got lots of little holes in it. And all of those holes...
hopefully I can bring that up properly. I don't know if anyone can see that. But if I peel the bottom back...
So that's the underside
of
the breadboard.
You've got the tracks, so these are connected along here, whereas the power rails are connected along here. So if I flip it, so these are all connected with each other. I'll now find something to point with. So all of these holes, A, B, C through E, are connected. Then there's a break here where the trench is, and then the next ones, F through J, are connected. And then if you look on the sides where we've got the red and the blue lines, these are all connected. So all the ones next to the blue are connected, all the ones next to the red are connected. And then that's typically your power rail. So you have your positive of your battery and your negative. And then here, if I take a random resistor here, if I slot it, say, into positive, and then I slot it, whoops, this is tricky, further down into just another random slot. That, hopefully, if you can, I don't know if you can see that.
It's a little bit blurry, but yeah.
Yeah, now connected between positive and a random line here. So if I had an LED with me, which I don't, I could then connect it from anywhere along this line onto a next line and then take it to negative. And if the battery's connected, the LED should glow.
Yeah. So basically, if you look at this diagram here that I've got up, you can see a breadboard has these holes that basically we can put the legs of components through. And on the underside, as Rob has shown, we've got these metal strips that basically connect all of these up. So when I show you, we've put a component like into here, and I've put one of the legs of the component into here. All of these holes are now connected along one of these metal strips. So it's like they're basically connected together, like we've joined them, but without having to do any fiddly testing, like twisting and stuff. Basically, they just slot into these holes nice and easily. You can pull this wire out, put it anywhere you want, and it's really good for prototyping circuits. So is that okay, Eben, or do you need me to explain a little bit?
No, it makes sense now. Thanks.
Okay, perfect. Right. So we are going to now introduce what we introduced at the end of the last session. So I'm just going to briefly go over it so that Eben and Daniel Get it? If I'm pronouncing your guys' names wrong, please just let me know and I'll correct it. Okay, so guys, I am just going to do a brief recap. So I'm sorry if you were there for the last session, but essentially, motors, Eben and Daniel, motors like this are denoted like that, and they look like this. We're going to use this one here. Okay, this is a motor, and it's got two terminals, a positive and a negative. Okay, and if we connect the positive side to one side of our battery, the motors will spin one way. If we then switch over the connection, the motor will spin the other way. Okay, this is how we get forwards and backwards rotation. So if you made like a little hobby car or something, you'd go forwards and backwards, and basically you'd have to switch over those contacts, right? Obviously, we don't run around making robots that we chase around the room, having to hold little wires and switch them over every time we want the robot to change direction. So we make these switch circuits, which is called a H-bridge. Okay, where you've got your positive side of your battery. And if you look at these switches 1 through 4, if we close S1 and S4, the current flows through our motor one way, right? Which will allow our motor to rotate one way. If we switch S2 and S3 on instead, you can see that the current flows through this way and the motor rotates in the other direction. Okay, so basically here you can see this is essentially doing the exact same thing as before. It's essentially just crossing over the pathway and allowing current to flow through the other way, changing the direction of the motor. Are you happy with that?
Yeah.
Okay. Now, we're going to take it a little bit further because, again, we don't want to be chasing our robots having to open and close switches. So we've introduced transistors briefly for you guys as well, which will basically allow us to replace the switches here with transistors. So this bit and this bit are exactly the same circuit, right? All we've done is we've replaced the switch S1 with our PMP transistor Q1 here, okay? Right, so if we now send a signal down these two transistors in red, we will allow the current to flow through and rotate it in the direction shown in the red. The same thing for the green direction, we rotate it in green, okay?
Yeah.
Yeah, perfect. Now, this is essentially what that would look like on a breadboard. And this is even done in Tinkercad. As you can see, it's a bit of a nightmare, okay? We don't really want to go ahead and do this. I don't want to have to check it. And I know that I could ask Rob to do it, but that's a little bit of a pain.
Get lost.
So we don't use this, essentially. What we do is we use a chip, okay? This chip houses all of these components inside, okay? If you can think of basically all these components are just a little bit bigger. Here, they're just really, really small, okay? And these chips, if you guys all go into search all and then search motor here, and I need you to find the H-bridge motor driver, this chip here. Select that and bring it onto your circuit. Okay. Now, basically what we do is when we get a chip like this, as you can see, there's a few things. Firstly, it's got a code. This code here identifies this chip as what it is, okay? Because there are chips for all kinds of things, and you need to be able to know what it does. So here we know that this is an L293D. If we Google an L293D and the data sheet, we will get something like this, which is basically a map, a pinout, which tells you what each one of these little pins here, pin input 4, input output ground, it tells you what each one of these does, okay? Second thing you need to know is that it has a, obviously all the pins are numbered 1 to 8 and then 9 to 16. We number them in this kind of anti-clockwise fashion. This pin 1 is either up here or it's here, right? The way we know this is because a IC has a little dimple in the top, okay? Here on Tinkercad, they've given you a little dimple and a little white mark. So I'm going to go ahead and rotate this. And that is now the right way up. Okay, so this now shows us the exact same thing here. So this chip, if I go to the next slide, basically has two halves. One half controls one motor, and another half that I've blanked out here controls another a second motor. right? So we can control 2 motors with 1 chip, whereas before we had to have all of this circuitry just to control 1 motor. Yeah, so now we've got twice as much on 1 tiny chip. So these are amazing. Okay, so what I'm going to do now is I'm going to show you guys this pinout, right? And I want you guys to try and connect up, if you can read that, try and connect up this chip in this fashion, okay, onto a new breadboard. So I want you guys to get your component, get a motor, get a new breadboard, and see if you can connect this up. One thing I will point out as well, actually, before you get started, I need you guys to search for an Arduino and put an Arduino down as well. Okay, so I'm going to write some things down here, but I need you guys to try and connect this chip on the breadboard to your motor and to the Arduino. So I'm going to explain the Arduino. This is going to go to 5 volts. That goes to ground. Can I ask, am I making any sense to anyone? I'm getting nothing back.
Yeah.
So, okay. On the Arduino, the pins are labeled, okay? So here, this pin is 5 volts. This pin is ground. These pins are all numbered 7 all the way, 13 all the way down to 0, okay? So when I write in here, I'm not going to explain this board. You're going to program these next week, so I'm not going to explain them now. Basically, these pins here, 1 to 8, if I write Arduino, it means that you need to connect it to the Arduino pin with this name, okay? So have a go and see if you can do that.
When you said motor control, do you mean one of the pins on the motor?
Motor control, this one.
Yes.
Motor control, no, so I need the motor controls to go to Arduino pin 7 and Arduino pin 8. Have I answered your question or have I confused you further?
I think I got it. I think I know what you're referring to.
Okay.
Do we have to code this? Or is it like
No,
a preset code?
no. So I'm not gonna ask you guys to code it. I'm just gonna give you a code. You'll learn programming next week in the programming workshops, and you will be programming these circuits. I'm just gonna give you the code in the chat. You just copy and paste it when I show you. I just want you guys to get this first bit done. We'll talk about the wiring, and then we'll talk about this, and then I'm going to show you one last little cool bit, but I'm not going to make you guys do it.
So for the ones that have plus 5 volts, you just need to attach it to any 5 volt pin.
Yeah, so you've got one 5-volt rail on connector on the Arduino.
Yeah.
Suggest just bring that across, and then you just connect it to basically this rail here, which is connected to 5 volts.
No, not there.
Yeah, you need it connected up here.
No, you've connected
sorry,
it to negative.
yes. Sorry, well done, thanks. Yeah, so connect that across to there. Jump it across to here.
And what about the bottom left one, motor power in? What do I connect that one to?
Connect that up to
Oh, like that. Okay, I see.
You can connect it up like that, or you can choose to, connect it up to the main rail. It doesn't matter. But yeah, all those 5 volts just go to the same rail. I'm going to pull a massive blue Peter again.
I think you'll find it's Art Attack, mate.
Is it Art Attack? No, Blue Peter were always like, here's one I made earlier.
I don't know, I never watched Blue Peter, but what was his name? Neil from Art Attack's like, here's the finished product, so...
Yeah. And now here's... Oh, yeah, he used to always just pull one out under the table.
Yeah.
I miss him. He's Banksy.
With the motor, you know the ones that connect to the motor?
Yeah, the green ones.
Those just connect to like any negative or positive. It doesn't matter, right?
Don't worry about the orientation of that.
Okay. And what about the pink ones? That's like
These
what is it?
purple ones here,
Yeah.
I need you to connect them to the Arduino. So the Arduino pin 8 and pin 7.
Okay.
Can I ask a question about H bridges?
Yes, please do.
Okay, so you can buy like H bridges online, but they come with like a circuit board. They're like on a circuit board. What's the difference between them and the one that we're currently wiring up?
They will have lots and lots of like transistors. Lots of capacitors and everything. That basically you usually go for one of those.
Okay.
Those boards will more often or not contain one of these chips, and they will just contain extra stuff. So basically they'll contain some voltage control and everything else. So ideally you choose those when we actually go for like a proper project. But you know, we're just going to explain the ins and outs through this at the moment.
Okay, so if I'm doing a project, use the ones that are already on the circuit board, not this.
Yeah, I'd advise
Okay.
not making your own.
Well, it
Okay.
depends on the project. If you're constrained for space and you know what you're doing, then you'd probably want to go for a chip and then build around it. But for something very basic, just get a pre-made.
Yeah.
Okay. Thank you.
But yeah, to those that did fundamentals last year, I know some of you are here. This is the same circuit as the main line followers we were doing.
So we expect you guys to nail this.
Yeah.
I was very sick during that time. My brain was like 50% functional.
It's all right. I'm only going to judge you a little bit.
Okay. I appreciate the leniency.
It's okay. Okay, I would like everyone to ignore this bottom bit. Okay, so guys, essentially what we've got here is an Arduino, right? The Arduino is basically the brains of our operation, and it's basically what we can use to send signals out of, right? So we can transmit signals using a bit of programming, and we can tell it what to do. Okay, so we'll get into this in a little bit. Essentially, here on our H bridge, okay, we've got our positive connected to, I've connected it to a smaller breadboard because I felt like it. You've got your 5 volts connected along to your top right pin here. Okay, so I probably should have specified that in the list, but it's here. You've got your top pin connected here, and we've carried that 5 volts across. Now this top left pin is our enable for our left motor, okay, because we're only working on the one side. So this pin up here, when it's high or when it has 5 volts sent to it, it will basically enable this motor to run. Okay, we'll be able to activate this motor. Okay. Sorry, is someone trying to ask questions? No? Okay. So we're sending 5 volts to this. I'm then going to take this down, set it to red. This pin at the bottom, this motor power in, this pin needs to have some voltage in it because this is the voltage or current that is going to go through our motor. Okay. So we basically send 5 volts to this top pin, to these 2 top pins. This enables the logic in the integrated circuit. This powers our motor, and this enables our motor. Okay. Now these 2 pins here, M1 forward and M1 reverse, the 2 purple ones, so pins 2 and 7 on our integrated chip. So if we come across here, I've made mine a light blue, and you should have connected those to both 7 and 8 on your Arduino. It doesn't matter which one you put round. And essentially, if you remember, when we looked back at our transistor circuits here, we had to send signals, remember, to our transistors. Yeah, so we have to basically close these switches. These signals, these 2 inputs, are basically what allow us to close and open these switches. Okay, so these are our inputs to our transistors. Okay, so these M1 pins are our control. We're going to choose the direction of our motor with them. And then we've got our 2 pins in the middle that are ground, and our 2 green ones which should be connected to your motor. It doesn't matter which way round you do it. Okay. And essentially, you've now got your thing wired up. So you've got your 2 grounds connected. We've just put 1 lead here. And what I've done is, instead of connecting my ground across from here, which you could do. You could also choose to do that. I decided, because all your grounds will be connected, and cheekily I've hidden these from you. The 2 grounds on this side and 2 grounds on here are all connected together. So you can take this across and you can choose to connect your ground from the other side. Okay, but it wouldn't have mattered if you decided to put this here. Okay, I'll do it there so it's easier for you guys to see.
Also, in real life, you'd struggle to cram 2 wires into one socket on the Arduino.
Yeah, you'd never really get along with that. But that's for you to find out when you actually look at these circuits later. Right, so what we're going to do now is I'm going to send you guys a bit of a code. So when I do stop simulation code. So what you're going to do is you're going to choose this code button up the top here. Okay. When you do code, it's going to give you blocks, text, and blah, blah, blah. We're going to choose text. You can choose to block code, but we're going to do text. Right, and then I'm going to write a little code here, which should have already... Oh, it might be in my emails. No.
You're kind of sharing this with everyone.
Yeah, I know, but I've got nothing interesting.
We are looking at Ben's private emails.
Oh my god.
Well, then you'll be fine if I dox you on YouTube then.
Yeah. Did not think about YouTube. Right, so guys, we're going to put that in there. I'm going to send you guys all of this in the chat. Basically, I want you guys to copy and paste this into your code bit here. Okay. And then you can start your simulation.
You know you don't have to type out the code, right? You can just copy and paste
Yeah,
it.
you can just, I would recommend just copying and pasting from here. Don't retype the code out yourself.
I can hear someone typing, that's why.
Wait, where am I copying and pasting it from?
From the Teams
chat on
chat.
Teams.
Fantastic. Right, so can you guys notice that when we run the simulation, you'll see a negative and a positive? Anyone tell me why that is?
Because it can run backwards or like forwards.
Yeah, perfect. So I'm not going to explain this code in detail, but essentially what we've got is in the loop, this bit we're constantly looping over, we're sending 5 volts, we're sending high, this bit, to pin 7, which is connected to one of our pins, and we're connecting low to the other one. Okay, so we've got a high one and a low one. If we look at this table here, basically this is kind of like your options. These are all the options we got. We've got our 2 pins, M1 and M1 forward, these 2 blue ones, 7 and 8. Okay, we have these 2 pins. We can either choose to send 0 volts to both of them. We can choose to send 5 volts to one. We can choose to send 5 volts to the other one, or we can choose to send 5 volts to both of them. Does that make sense? Is everyone following?
Yeah.
Ben?
Yeah.
So high represents 5 volts.
Yeah, so high is what we call 5 volts. You might say it's positive, high, live. These are all kind of the same names for the same thing.
Okay.
In the same way that you might say ground, earth, negative, 0 volts. It's just kind of different names for different things.
Okay.
Now, I will just clarify here. High in our case is 5 volts because we're using 5 volt logic. Okay, that just means that everything is basically either 5 volts or 0 volts. Okay, so in our case, this is what it is. So when I send high, I'm sending 5 volts. When I send low, I'm sending 0 volts. So here you can see that as we alternate, because then we delay for 1 second, then I switch over the low and high. Okay, when I switch over the low and high, I'm basically performing this switch here, which means that we're switching between forward and reverse. Is everyone happy with that?
Okay. Oh, because it does go to halfway, then you have to apply it again in reverse, so it does a full
Yeah,
turn.
so it's basically sending the signals 0 and 5 volts. Sorry, 5 volts and 0 volts. 5 volts and 0 volts, so it's going in reverse. Then it waits a second. I'm not going to go too much into the programming. It waits a second, then it switches them over. Okay, and this is basically how we programmed our motor to go forwards and then reverse, and then it waits again, and then it loops over and it goes forward, reverse, waits, it loops, and it goes over and over and over again. Okay.
Okay.
But this is essentially how we have programmed the switches, and I want you guys to think about this, on our transistor circuit. We're basically just opening and closing these switches. Yeah?
Okay.
So that's what we've accomplished. Now, there's one last thing that I'm going to show you guys, but you guys don't have to follow along because I know we've been going for 2 hours and a bit, so I don't want to keep you here all day. But if you wanted to, remember our transistors from before. Actually, no, let me show you this. This is more interesting. We know that DC motors, if we increase the voltage to them, will go faster. Okay, so right now we're running it off the 5 volts that comes from our Arduino, and it's going at a set speed. Okay, we could choose to increase the voltage to our motor. However, the Arduino can't provide that power. It can only provide 5 volts maximum, right? This pin here, motor power in, this bottom left one, we currently have connected to the 5 volts of our Arduino. Okay, I can choose to get rid of that. Oh, sorry, if I can. Oh, sorry, I'm still editing my code. That's embarrassing. Close the code. We should choose to get rid of that. I can connect this now to my battery here. Okay, so I can connect my 9 volts instead to that pin, right? And then I need to connect my negative. My negative needs to connect somewhere to the ground, right? We need to have a common ground, as we call it, because otherwise the circuit isn't closed loop, right? The current can't flow from my battery unless we close this circuit. So we need to connect it to a ground, and we can do that either here, on the chip, anywhere we want, okay? As long as it's on a mutual ground, as long as there's a ground connected. So we connect that to the ground, and now when we start our simulation, can you guys see that this number is a lot higher? It's spinning at higher revolutions per minute.
Okay.
It's now spinning at 244. I think you'll find that your guys' one spins at 140.
Yeah.
Okay. So this is just saying that voltage, increase in voltage to that pin, we can now apply more power to this pin to increase the speed. Okay. Now I think Ryan might take you through some stuff next week. But essentially, want you to know that this is basically the speed pin of our motors, and I think that's probably enough. One thing we could do is we could do a potentiometer across there, and you could vary the voltage and you could change the speed of your thing. Does that make sense? So if I take a potentiometer and I take terminal 1 across there, terminal 2 across there, like so. Actually, no, why am I doing here? I'm just going to connect a potentiometer up. I'm also going to remember we need to connect the negative. We need this common ground. It's a very, very important thing. You could have the circuit, the electrons running in this circuit, but they're not going to flow into our other circuit if we don't have our grounds connected. Right, so here, can everyone see kind of what I'm trying to do? Yeah. Right, so now I should, oh wait, that's got a very high resistance. Okay, so now can everyone see that as I increase the resistance, I'm changing that speed?
I see.
Yeah. So this is how we can vary the speed to our motor. Okay. And you can fiddle around. If you change the resistance on this thing, you can experiment with how it changes the speed. Yeah. So that's full speed. I apply some resistance. We reduce the amount of current going into this this pin here, and we reduce the we reduce everything going through the motor, and it slows down. Everyone happy with that?
Yep.
Yeah. Okay. Cool. So next week, you guys will be basically building on this and programming these boards and learning how to do all of that with some sensors and other stuff as well. Okay. I hope you guys learned something from today's session. I hope it was somewhat useful. One thing that I want to do, Rob, can you put in that link?
Yeah.
So just before you go, guys, Rob's going to send in a little link. It's got 5 questions to it. If you could just leave a response about how you found this session. We're trying to just look for feedback. I'm not looking for praise. I want
How do I say
constructive.
this?
Sorry, it's just been commented here. So Rob has just posted a Google Forms link. If you guys could just provide feedback on the session, things you didn't like, things you did like, things you'd like to have more of, that would be a great benefit. We're trying to improve all the time, okay? If anyone has any questions, I'm still going to stick around and you can ask them, but otherwise this session is over. So thank you, guys.
How do I save this?
Thank you.
How do you save it? It's
Yeah.
automatically saved. So every time you
Okay.
log back to Tinkercad, it'll just be there for you.
Okay.
No worries.